let's dive in by talking about what World Machine is and what it does. The main thing that we will use to create any terrain in World Machine is a height field, because that is what World Machine is. It's a height field generation software. It will also give you meshes and color maps and all these other cool things, but at its core, we're going to be working with height fields. Now, a height field is basically just a 2D map that tells you how tall something is. So let's try it out. I'm going to go to the generator tab and create an advanced Berlin node. Now, an advanced Berlin, this is one of the most typical noises that we use in any 3D software out there. And so when we have this thing, let's go to the 3D view. This is what it looks like. Generic mountains and valleys and lots of little fractal detail. Now, this is the 3D simulation. Let's see what it really looks like. Let's go back. I'm going to right-click this device and change the display hint from normal, which is the default, so whatever that device is supposed to be by default. This one's supposed to be a terrain. We're going to go to mask. Now if we go back to our 3D view, you can see this is what the terrain looks like as a height field. The brighter something is, it's taller, and the darker something is, it's lower to the ground. Now let's change this back to the normal terrain mode. Now, you'll notice this is a fractal. So there are two ways you can create something in World Machine. One of them is by using a combination of procedural noises like the Berlin noise or Voronoi or lots of other things. Or you can actually hand draw something. So I'm going to create a quick layout generator, and let's double click it to go inside, and we'll make a simple vector shape. And let's go back and see how it looks like in 3D. So we just created this little thing by just creating a shape. Now, between these two, you will get a fantastic level of control over what you want in your final terrain. So let's start by creating the most basic terrain you can. I'm going to delete our layout generator, and let's create a second window, and I'll resize it so we get a larger preview of what's going on. So with the second window, you can change it to be any specific view that's helpful to you. I always prefer having it in a 3D view, and then you can use your cursor keys to move it around, and you can use your mouse to just go in and out and just inspect what's going on. By default, of course, this is an unbuilt terrain. If you see a little yellow swatch here, that means it's not built. So to build it, you go and click the build button. It'll build, and now you can see it in full detail, and you'll notice our little indicator here has turned to green, which means it's built. So let's just take this and create the most basic terrain that we can. So the heart of World Machine is its natural erosion, and so let's just erode this terrain. So to do that, I'm going to go to the Natural tab and create an erosion node. So the erosion device is going to take our Berlin fractal and change it from this to this. And this is not just loss of detail because it's not built yet. You will notice if you take a look at this area, it's actually creating soil flow. So we take your basic terrain and go back here, and you'll notice here. So let's build just with the default settings, and we'll see what happens. So you'll notice we are building at 2048. They'll stay there. It's the middle ground. It gives you just enough detail to check things out, but isn't too time consuming. And I personally like to stay there if I'm dealing with a particularly complex terrain. Then I'll go down to 1024 but most of the time this is a really good sweet spot. So now, if we look at the eroded terrain, you will notice some erosion has taken place. So we go back again to match, and here you have fluvial lines, which are created when water flows through the drain and erodes it as it goes along. So this is looking cool. Let's go and make this look better. So I'm going to open the erosion device. So the simplest thing to do is, of course, change how long the erosion is going on. So if we go lower, then there's no erosion. If we go high, then there's lots of erosion. So what we also want is to have strong soil flow so that it looks cool and it looks realistic, where soil has dragged on and changed the shape of the rock and the terrain while it was going through that process. So to do that, we'll amplify the sediment carry amount, and there you can see that the shape has changed dramatically. So the last thing I want to do is just increase the rock hardness, because I don't want to completely lose the shape that we had. But this should be enough for the moment. Let's build this. And now we'll see, of course, because of our increased settings, this is taking slightly longer. Now once this is done building, we'll be able to see just how strongly the soil flow has occurred on this terrain. Now let's zoom in. You can see it's far stronger than before. Let me increase the window so you can see better. Here you can see cool new shapes. These are all fluvial flow lines, and they are what make a terrain look really believable, because when you look at a satellite map, zoom out, this is the kind of stuff that you'll see. So it'll find the weakest points in the terrain and start flowing the soil through it and do what nature does in real life, but we basically get to do eons and eons of work in just a few minutes. Now, this is the simplest terrain you can create. You create a shape, erode the shape, and then you save it. So now let's do something slightly more advanced. What I like to do is let's delete all of this and change the window to smaller size again. I'm going to create a slightly more complex a scenario. So if we're going to go through a basic pattern that you will find yourself using whenever you create terrains, it is you create, modify, and erode. So just having a fractal is not always enough, because once you have just the same Berlin noise again, it will look like it's the same Berlin noise again. What you want is to have creative looking terrain. So let's create a mix. So we're going to create an advanced Berlin again. So here you'll see this time it's created with a different seed. So let's go in and take a look at what's happening. So first of all, of course, we have the scale of all our features. Do you want to be little boulders, or in this case a horrific set of needles, or do you want to be little hills or mountains or giant continents? I think we'll be pretty satisfied with mountains at 8 kilometers. That's the scale of this little square. And this is a good time for me to point out that when you start a new World Machine scene, unless you have some very specific settings, it'll always be set to 8 kilometers. You can change that by going to the World Extents and Resolution dialog. So this is basically just your project settings, where you can choose how large this area is that we're building. So when you build that area, you're basically taking a near infinite world, which you can see if you go to the layout view. So if I go to the layout view, and this little thing here is part of a much larger world. So this is infinite, and it'll keep going until you keep zooming out. So if we click zoom to extents, it'll go to this region, and this is what we're seeing. So if I turn this around, you'll notice these features are these features, or actually I think I might have it upside down. Let's change that. There you go. You have this little peak. That's this one right here. You can change the extents by going to set current. And so this is our current extent. I think let's make it a little larger. There we go. And let's go back to our device view. And let's open the advanced Berlin again. You'll see this is pretty much the same, but just a little bit zoomed out. The reason I did that is when you want to create large, expansive scenes, which is something I think we should try with this in this next terrain we're going to build, you need to be very, very careful about scale. I can't stress this enough. Scale is very important because if you start trying to build a small 8-kilometer terrain, but have it then be stretched out later on in whatever 3D package you're going to take that into, or worse, a game engine where you're really up close to the terrain, it won't look real. It'll just look forced. And most of the time, the users or the viewer who is possibly not a CG person may not recognize it, but it'll just look off. And it'll just take away from the feeling of awesomeness that you want to achieve with a grand terrain. So let's go back to our advanced Berlin. This time we get to keep the 8-kilometer scale, but we get more features, which is what I kind of wanted when I went to change the scale. So now when we do erosion or other processes on top of this, they will feel more realistic for the scale that we want. So now let's just take a quick look around some of the things that I really like about the advanced Berlin. The first is the number of octaves. So the octaves are the iterations that a fractal goes through to create detail. Right now it's on auto, so it's going to go for as much as it can just get in. So if I change this to 1, you'll see it's a pretty blobby looking thing. And the more you go, you'll notice it's just adding better levels of detail. So this is your level of complexity. More often than not, you'll end up finding yourself using auto. That's pretty good. But in certain cases, as you'll see when we start building more complex graphs, it comes in handy to have something that's not completely all noisy with as much detail as you can get. One of the things that's relevant for what I want to do right now is the persistence level. The persistence is basically how sharply do you want the features to displace the terrain. So 0.5 is the default, which is the resting point. I think let's make it slightly less because I don't want to have a very sharp terrain that has too many small features. But of course, because of this, we lose a little bit of our height. You still need to have good, decent height. So that's where the elevation and steepness comes in. With the elevation, you can raise the elevation of the entire terrain, and with the steepness, you can make the lowest parts go lower or make them rise up. This works exactly like bias and gain. So if you ever use that in Photoshop or elsewhere in any fractal program, then you'll know exactly what this does. And if you haven't, then when we get to the bias and gain filter here, you know it works exactly like elevation and steepness. So one last thing before we close this window is that style for our Berlin. The Berlin noise is very, very cool because it can easily be modified to so many different levels. So we have all these cool options. So right now we're working with basic. If I change that to ridged, it has a lot more ridges. Not completely visible right now. If I were to change the scale a little, you can see it's very ridged. Now let's try billowy. Now this creates lots of blobby, billowy rock formations. This is great, especially for adding on top of something that's sharp like the basic or the ridged. So I actually like that idea. So let's do that. What I'm going to do is I'm going to just go back to the basic and let's increase the size to 8 kilometers. There we go. And click OK. And let's create a copy of this by using Control-C, Control-V. The reason I'm doing this is I like the blobby pattern that we saw in the in this one, and I don't want to create a new one because that will just create a new random seed. So the random seed is basically just a random pattern that this will use to create whatever a fractal it's going to create. You can just click new and it'll just randomize the shape. So again, I don't want to mess with this one, so I'm going to click OK, create yet one more Berlin, and let's just randomize it to see what happens. So this way you can get as many shapes as you want. So let me just remove this unnecessary device. Let's go to our second advanced Berlin, and this time let's go for billowy. So that looks cool. I think I would like to see a lot more boulder, so we're going to change the size from mountain to slightly between hills and mountain. Now we get to possibly one of my most favorite devices in World Machine, which is the combiner. So the combiner does what the name says. It takes two different devices, just combines it. And here you can see an amalgam of the two things that we just created. So this is the basic Berlin, and this is the billowy Berlin. And if you combine them, it creates this. So it's neither this, nor is it just this. So when we open the combiner, we get to choose the method of combining and then the strength. The strength right now is 0.5 by default, which is equal parts of both, and it's averaging the two, so it's literally equal parts of both. You can change the balance as you like. If you would like certain features to be more prominent than others, then you can obviously choose. And you can also change the method, so you can use the additive method, which will take A and add B on top of it. You have to be really careful because this is the most common side effect of just using add without controlling it much. You will see that the mountaintops are flattening. That's something you would like to avoid. So let's just go a little lower, where we're not flattening anything out too much. And so what we get to do now is we get to keep this, but add a little bit of this. So there. Now it may not look like that much of a difference, but what you're doing is you're taking a very specific pattern, and because it's a fractal, the pattern will keep following everywhere, even though it looks slightly different in every different part of the terrain. It still looks pretty much the same to the software. So by adding this very distinctly different change in that pattern, when you erode this, it's going to look a lot different, because the erosion at the software level will experience a different fractal than the simple repeating thing that you get with just one. Now, we're not going to go erode this just yet. Let's go to filters. Now, these little things here, they all do something tiny and small, but they're going to help you create like dramatic changes for everything. So let's try simple transform. This is a handy device that can transform your terrain on a few different fixed patterns. So if you open it, you'll get to see you have height transforms and kernel transforms. So height transforms are basically, it'll take the height field and give it that one singular type of processing that you choose here, and of course you get to choose the level of intensity it's applied with. So let's say if you want to turn this into canyons, then you simply go canyonize. Or if you want to just glaciate it, which is basically erodes, kind of like glaciers do, but at the bottom level. So this kind of raises it, this glaciates it, so it drops it. And of course, you can create cubic midlands, which is really helpful because if you want to just even out certain things, and then midland plateaus. So the midland plateaus are really cool if you're creating like a Grand Canyon style thing and want to have like little flat areas. I think that looks pretty cool. So let's leave a little bit of that so we get this terracing. But as you'll notice, it's only happening here on the middle levels. So our mountains are left alone, and our valleys are left alone, but the middle part is kind of like flattened out. The kernel transforms are basically just simple smoothing filters that you can use instead of a blur. Right now we don't really need any of them, so we'll leave them alone, but just to see, you can, it's a very tiny difference, but this will smooth out little features, and the height varying low pass filter will smooth out edges and other little features. And of course, when you choose all the settings that you want, you can amplify the overall application of the height transform, so you can intensify all of this with the intensity modifier. So this is not to be used lightly, because I just basically destroyed an entire world. So let's go back, leave it at 1. That looks pretty cool. I think now we can go and erode. So let's go back to the natural tab and let's create the erosion node. So this is again a default, so you can see the device has started working its magic on the edges. Instead of making it like this, it's already started making it cool with all these soft soil flows. Now let's go to the erosion device, and what I want to do here is, instead of using the standard erosion, I want to go for channeled erosion. So channeled erosion is where it creates all these soil channels, and it just makes everything look cool. But you have to be careful not to overdo it, and we'll take a look at how not to overdo it and how to have a little subtle, realistic impression of this in one of the other exercises. But for the moment, let's just go all out and make this look as cool as we can. So I'm going to increase the channel depth. Now this thing is disabled until you go to channel erosion. If I go back to standard, this is not going to work. So if I go to channel, you can see it's creating these deep grooves. So these fluvial erosion lines are just fantastic. And what you can do is, on top of that, you can add post-channeling erosion. So once the channel has been dug out, you will add more erosion on top of it, so the channel doesn't look too freshly grooved out, like somebody went there with a pickaxe or something. So let's leave this at 40%, and this here, all of this is still at standard, so I think let's just increase this a little. Oh, that might be too much. Okay, I'm going to lower that. I'm going to increase the rock hardness, because we definitely don't want to lose our cool midland plateaus and other stuff. So one more thing we can try is the geological time enhancement. So this basically takes this and multiplies it by centuries, or some higher quantity of time that, or unit of time that I can't think of right now. So here, I just clicked enable, and you can see everything becomes transformed dramatically to a heightened state. So we can go lower, we can go higher, we can go all out, and you can see this just went from Grand Canyon to something super Everest-like. So okay, we're not going to do that. Let's go back. I like it being around here. It's strong enough to give us cool stuff, but not too strong that it'll take away all that we have created. So anyways, I think this is pretty good. It's time to build. So again, you'll see at 2000, it's a pretty fast build at 8 seconds. So there you go. Now, in fact, let's actually hide this, and let's go to full 3D view here. Now this is what's making this terrain look really cool. All this awesome erosion. So if you go to ground level, where you might end up placing your camera in your 3D package, or if you're in a game, you can see this feels very natural. And again, to refresh our memories on just how unnatural this was, no matter how cool it looked before, let's go to the combiner. This is what we transformed by combining two different fractals. So we have this guy and this guy, which created this, and then we transformed it into this, and that finally became this. And you'll notice like all these cool grooves that I was talking about with the channel erosion. Let's just fly around the terrain a little bit. So this is looking pretty awesome. And there's only one way I can make this look even more awesome right now, and so we'll do that by using the flow map. Now, this is something that you'll find very useful when you are creating textures, whether right here in World Machine or taking it to wherever you're going to make them. we need masks. We need the texture to always follow certain patterns of the general shape of the terrain. And so to do that, again, let's bring up our preview window so you can see what I'm doing. I'm going to reset this view. Okay, this looks good. So I'm going to create an output device called the overlay view. This is kind of like an equivalent of rendering in a way, even though there's no real rendering that's necessary here. So what you do is you give it two inputs. You give it your height field, which will create the terrain, and then you give it a color map. So to do that, we're going to create a converter device called the colorizer. So the colorizer takes a color pattern. We have lots of different ones, so I'm just going to choose this one. And so this thing will take a height field and remap the gradient accordingly. So let's say if I were to send this here, which is the primary output, just what you see is what you get, and then I will connect the primary input of the colorizer also to that. And then if we put it to the overlay view, you'll see this gradient ramp has been applied to the terrain based on heights. So the higher something is, it'll get this range, and the lower something is, it'll get towards this range. So this is equally distributed. Now, we definitely don't want to do this because this looks too simple. What we want to do is make it really cool. So we get three different things. We get the flow map, the wear map, and the deposition map. So we're going to go with the flow map. And the moment you apply the flow map, you can see this just became different. And now, when we go here, actually let's go way down here so we can see. And to get a proper resolution preview, we need to rebuild. And of course, only the devices that were not built are going to be built now. So here, we just added to the coolness factor of this terrain by taking all these flow lines and giving it a texture. So this is how it often works in nature, although this is a pretty stark example, but looks cool, and also illustrates just how powerful the erosion device's masks are. So this is one way of doing it. Let's try another one. Instead of going for the flow map, let's go for the deposit map. So here again, so this is slightly different. This is no longer looking at where the journey of the sediment flow, which is the flow map, like where it started and where it ended up. This is looking only at where it ended up. And the height field that we are using, let's just take a look at that to see what we're getting. So I'm just going to create a height output node, which you can create from your favorites, or if you have them there, or you can go to the output tab, and it's this red floppy disk icon. So let's create this height field output, and I'm also going to connect that to the deposit map, and this is what that looks like. It's just basically another height field or a mask. If I build this, you can see more detail. And so this is what's being taken to the colorizer, and the colorizer is putting color to it based on what it has. Now, let's try a couple of different things. So I want to change the color of this, but I want to keep looking at what's happening here. So I'm going to go and to the overlay view. I'm going to click lock preview. You can also do this by pressing the F key. So what happens now is I can go anywhere, but the preview is always going to be this thing, whether it's here or in your 3D view. So now if I go back to colorizer, I can try a few things. Let's just simply even out the gradient by clicking space evenly. That changed it a little. And if I change the color here, that changed it a little. And of course we can always just go through different presets. You can see this can help you get a look established for the terrain, and also figure out how you would like to texture it later on. And you use the same constituent components like the flow map or the deposit map or wear map and other things, as we'll see. And so when you color it here and you take those same masks out into your main 3D application, you can redo that entire process and get a very similar result. So I think we're pretty good. Now let's take a look at the most important thing that you'll have to do once you have your terrain, is to output it. So you create an output device just like we did for the deposit map, and this one I'll connect to the main output. And so we double click this to set our options. You can choose a format, 8-bit or 16-bit. We'll take a look at what's the best thing to use at a later chapter, but 16-bit is always better if you can have it, because that will create a very solid height field without any banding issues or problems. So you just select your format, set your file name, and build. Your device needs to be built. Once it's built, you can go back here and click Write Output to Disk. Now, we also have a flow map, or rather a deposit map. That is usually better at 8-bit, so I'm going to leave that as an 8-bit TGA file, and rename this to output_deposit. And you can save this as well because it's all built. It's mandatory that this needs to be built, otherwise it may not export the right form resolution. So anyways, this is done, and you can click the write output to disk on both, or you can go to the export terrain dialog and just select export all.